Hello, Algebra 2. This is the second day of 754, which is dividing complex numbers. So you started this before spring break, and now we're going to review some things and get some more practice today. So this is the handout that you should have downloaded from Veracross, and there's a warm-up in here if we had been in class in person. We won't do that today. What I want to do is just review some of the types of problems that you had from your classwork from before break. Just to kind of refresh some of the basics about how we do this. So one of the, let's see, I think number one, it was something like 3 over I. And so the problem with this is that you have your imaginary number or your I in the denominator. And so to get rid of that, you can multiply it by I over I. And so if you just multiply across your numerator, well, that's pretty easy. That becomes 3i. And then your denominator, I times I, is I squared. And remember, I squared is the same thing as -1. So what this turns into is 3i over -1, or just -3i, okay? And so that's the best way to write your answer for number 1. For number 2 from that classwork, you had 4 over 5i. So this one's a little different because now we have a number in our denominator, but we can still just multiply by I over I. So we'll get 4i over 5i squared, right? And then I squared is -1, so this turns into 4i over -5. And you could leave it like that, and you would get full credit for that. That's completely correct. Or what you could do is you could take the I out of the fraction and rewrite this as -4/5 I. And that's also completely correct. So those are the basic kinds. You had one more kind, maybe something like number 3. We can take a look at this. You had to do 2 minus 3i over -4i. And so to simplify this, you would multiply by I over I again. And so up top, we've got some subtraction going on. So that just means you have to distribute that I across. So that would give you 2i minus 3i squared. And then down below, we would have -4i squared. Okay, so we've got to go ahead and simplify this. So your numerator is going to be 2i. And then remember, this I squared is a -1. Okay, so it's kind of like, well, if you take that -1 and throw it in front of your 3, it's kind of like you have a -3. And then that -4i squared, that's going to turn into, well, that I squared is another -1. Okay, let's see, that's another -1. So it's kind of like you have a -4, and all those double negatives are going to turn into positive. So we'll have 2i plus 3, and then this will be over +4. Okay, now you can leave it like this as 2i plus 3 over +4, or what you can do is, well, actually, what you should do is write your real number first. You should write it as 3 plus 2i over 4. You should at least do that. You can, what your textbook likes to do is go ahead and split things up. And what they would say is 3 over 4 plus 2 over 4i. And then they would take that 2 over 4i and reduce that to 1/2. So let's see. They would say then that's 3 over 4 plus 1/2 I. Okay, so either one of these is completely correct. You can leave it as one fraction, or you can split it up and reduce it. I would give you full credit for both. So those were the kinds of problems that you did in the first day of 754. And so now what we're going to do, you had some more of the ones we're about to do, but we're going to practice them more right now. So the other type that you had were the ones where your denominator is a plus bi or a minus bi. So you've got some addition or subtraction going on. And for those, you're just going to multiply by your complex conjugate, right? So if it's a plus bi, you multiply by a minus bi over a minus bi. And if it's a minus bi, you multiply by a plus bi over a plus bi, okay? So we'll go ahead and start with this classwork. So for number 13, okay, we've got 3 plus 6i over 4 plus I. So the complex conjugate of that denominator is going to be 4 minus I. So we'll multiply by 4 minus I over 4 minus I. Now in your numerator, to deal with your numerator, you'll just FOIL that, right? So you can pretend that you have parentheses around either set. And so if we FOIL that, well, my first 3 times 4 is 12. My outers, I'll get negative 3i. My inners will be, let's see, 6 times 4, that'll be 24i. And then my last, that'll be negative 6i squared. All right, and then for your denominator, well, there's a shortcut when you're multiplying complex conjugates. So we can say this is a shortcut for complex conjugates. This is the only time it works. Okay, so to multiply those, the shortcut is the first number squared plus the last number squared. So when I'm talking about the first number here is your 4, right? So I'll have 4 squared. And then your last number is the number in front of I. It's not I. You don't include I there at all. It's just the number in front of I. We don't see anything in front of I. So for us, it's just going to be 1, right? There's a 1 hiding in front of that I. So then we have 16 plus 1, which is 17. And so this is our denominator. Right, so we would kick this up here. So we've got 17 right there. And then we would take that and simplify all of that. Okay, so let's go down here and simplify this. So I'm going to have a 12. And then negative 3i plus 24i. Combine those terms. That'll give me a plus 21i. And then the negative 6i squared. Well, remember that I squared turns into a negative 1, right? So that's going to flip that sign on that negative 6 and turn that into a positive 6. And this is all over 17. Okay, so one more step here. So we know 12 plus 6 is 18, and then we have plus 21i. And this is all over 17. Okay, so that's the best way you can write your answer, 18 plus 21i over 17. So let's go on to number 14. So we'll multiply this one by 5 minus I over 5 minus I, okay? And so again, we'll FOIL in our numerators. So if I do my firsts, well, 4 times 5 is 20. My outers, 4 times negative I, that'll be negative 4I. My inners, let's see, 5 times 20i, that'll be plus 100i. And then my last, 20i times negative I, that'll be negative 20i squared, okay? And then, so we can use the shortcut on our complex conjugates down below. So remember that shortcut is your first number squared plus your last number squared. So my first number is 5, and then my last, that's the number hiding in front of I. So that's just 1. So I'm going to have 25 plus 1, which is 26. Okay, so now we can go ahead and simplify things. So I've got my 20 starting things off. Negative 4i plus 100i, that's going to be plus 96i. And then that negative 20i squared, well, remember that I squared is a negative 1. So that's going to reverse that negative over here to a positive. Okay, so then we have plus 20. And then this is all over 26, right? So we want to combine some things here. So 20 plus 20 is 40. And then I have plus 96i all over 26. Well, 40, 96, and 26 are all even numbers. So they're all divisible by 2. So that's going to give us 20 plus 48i all over 13. And that, you can leave your answer like that, or if you want to split up your fractions, you can go ahead and do that. Okay, so that was number 14. So 15 looks a little different from the other ones we've seen in that your denominator has subtraction in it. Well, that's no big deal. That just means our complex conjugate is going to have addition. So we'll multiply this by 3 plus I over 3 plus I. Okay, so we can pretend that we're FOILing out our numerators. So if I multiply my first, 6 times 3 is 18. My outers is going to be plus 6i. My inners, that'll be negative 9i. And then my last is negative 3i squared. Okay, and then down below we use our shortcut. So we have 3 squared plus 1 squared. So 9 plus 1 is 10. So 10 is my new denominator. Okay, we'll kick this down here and combine like terms. So I've got my 18, 6i minus 9i. That's negative 3i. Negative 3i squared, remember, I squared is the same thing as a negative 1. So that negative there is going to reverse that negative that's in the problem. So that's going to turn into a plus 3 all over 10. And so this turns into, well, 18 plus 3, we've got 21 minus 3i over 10. Make sure that looks like an I there. Let's see, so 21, we said minus 3i over 10. And that's the best way we can write that answer there, okay? So let's see what else we have. If we go down below, well, 16, it's kind of like what we just did. Well, 16, 16, we can skip over that one for now. 17, okay, so 17 is different than what we've been doing because we've got radicals there. We don't have anything as a simplified imaginary number. So we'll go ahead and take a whirl on that one. The first thing we would do there is take those radicals and rewrite them as imaginary numbers. So this is going to be I root 12 over root 3 minus I root 6, okay? Now, the complex conjugate of our denominator, well, it's the exact same thing you have in your denominator, except you take that minus sign and flip it to a plus. So I'll have root 3 plus I root 6 over root 3 plus I root 6. Okay, so multiplying the top, we take that I root 12 and distribute that across. So I'll come down here, okay? So I root 12 times I root 3, well, we'll have the I in front, and then the 12 and the 3, we can multiply those and throw them under one radical. So that'll turn into root 36. All right, and then I root 12 times I root 6. So I times I is I squared, and then root 12 times root 6, we'll throw that under one radical, multiply those. That turns into root 72. And then so down below, we can use our shortcut. So remember, first number squared plus last number squared. Well, your first number is a root 3, so we'll square that. Your last number is a root 6, so we'll square that. So whenever you square a square root, you just cancel out the square root. And so the answer is just the number you have inside your square root without any square root. So that's going to turn into 3 plus 6, which is 9. So 9 is your new denominator. So we've got a few things that we can simplify here. Well, the square root of 36 is 6, so that's going to be 6i. I squared is a negative, so we've got that negative there. And then root 72, well, let's take that 72 and break that down into 36 times 2, and then this is all over 9, okay? So, well, we know the square root of 36 is 6. So let's see. Well, we've got 6i minus 6 root 2 over 9. And I would really like to write this with my, let's put our real number first. So that means we'll have 6 root 2, let's see. Oh, that's a negative 6 root 2. Yeah, so negative 6 root 2, and then plus 6i, and then this is all over 9. Now, the numbers that we have outside of our square roots are all divisible by 3. So I've got a negative 6, a 6, and a 9. Those are all divisible by 3, so I can do that and reduce this to lowest terms. So this is going to turn into negative 2 root 2 plus 2i all over 3, right? And so that's your answer there, and probably the best way to write that. Okay, so that was number 17. We'll go ahead and do 18 because that's the same kind of thing.